Super plasticizer, okay. What else?
Water reducer.
Water reducer is super. It's super plasticizer.
Oh.
No fly ash. No. No. ECM. It's another component of concrete. It's ECM. ECM. What is ECM? Supplementary cementitious material, like fly ash, slag, that kind of. Okay.
What did you write in there? I can understand.
Here,
Yeah.
admixtures.
Then
ECM.
ECM.
SCM.
SCM.
Yes, supplementary cementitious material. Okay. Can you give me just the percentage of each? How much we have cement? How much we have? Do you know? Little bit.
But there is no percentage in here.
How much you have cement in concrete? Percentage how much?
7%?
Cement is 7% to 50%. This is the basic information that you should know. I think it's I saw the exam of last year. I think this is the first questions. How much aggregate? It's up to from 60% to 70%. Okay. Water 20%, 8%, and the rest.
5%? 3 to 5%?
What?
3 to 5%?
Well,
Admixture.
admission c'est le reste, the rest.
Okay.
Okay. Uh,
7 to 15%. Purchasing.
But there is nothing written here.
No, déjà, why we are choosing this concrete as a construction material? We have several benefits. First, it's cheap, the cost. Second is the resistance, so we can build lots of buildings. Also, durability. So the buildings, not like steel bars or something, concrete give us surface life 15 years, like that. That's why we are choosing to use concrete. Now, for this, the simple mixtures,
Just erase that.
Okay.
Just from our last class.
for this component, we have a lot of type of concrete. Do you know some of them or not?
Lightweight concrete, normal weight concrete.
What is the type of concrete?
CM1.
Self-compacting concrete.
Okay.
Géobiologiquement concrete.
Ok. Il y a le self-compacted SCC or self-consolidating concrete. Il y a je connais le mot en français mais pas en anglais. Béton de masse. I think mass concrete. I think I will talk one by one here. Mass concrete. OCR. So ordinary concrete. Ordinary concrete. Ordinary concrete is the most used one that we can use to build anything. Okay. So what is the self-compacting concrete and why the benefit of this?
It takes less water.
Not less water.
It has a very high, good flow. Like
No.
It's flowable and it can
Yes.
feel
And you can
It's the
tighten
fluidity. The fluidity is high. Why this is more important? Because when we put the concrete in the mold, we need vibration. Why we use this vibration? The first important thing that the concrete take into place, take the form of the mold. The second thing is to
Avoid the voice.
hmm?
Avoid the
Avoid error.
avoid errors.
Yes, to this is fluidity. Sorry, it was fluidity. Okay. And in this type of concrete SCC, self compaction concrete, we don't need vibration. So just we put it and we go. We use this type of concrete in the case of reparation. For example, we have an old building. We can see some fractures, so we can put SCC. Mass concrete is used in the case where it's a concrete with the c'est un béton lourd with the mass great mass.
Weight.
The weight of concrete it's too high. Why you are using this concrete? We use it in the case of barrage. Huh?
Then
I think.
narrow strip or the narrow strip where
When we have lots of waters and we need to block this water,
oh
c'est le barrage.
then
Hmm?
where then
I don't know. Okay? Because in this type of structure we need the weight of concrete to stop the water and that's why the problem of this type of concrete and can you just write? The problem of this type of concrete is we have an exceed of heat. I think you see the hydration
high temperature
high heating the hydration heat. I think you have seen that. You have seen this figure. I think is like that. I think you have seen this one. To be clear, in the cement chemistry, 100% you will have this question in the exam. I think Sonia will give you, because she likes these things, Sonia will give you this figure like that, and we have lots of steps, and you need to name these steps. You have this one in your. I think you have this one. Okay.
So what is it? The heat of hydration or the cement? What is that?
This is the evolution of the heat. When we mélange the cement to water, we have a heat. So this heat should be controlled. Okay.
Is that DCR? OCR? Okay, OCR. The bottom is weird. So that should be OCR.
It's okay, Angela?
can I
Yes, yes.
in the metal concrete after that what you write in there
This one?
yes
Ça, c'est le. C'est concrete, c'est un béton compacté au rouleau. It's type of concrete.
CCR
Yes,
okay
it's used in the road. It's très compact. We cannot vibrate a lot.
yeah.
It's too.
For dry concrete
Lot. It's too dry concrete like that. It's,
So
it's the inverse of SCC. SCC is too fluid. This is too dry.
So is it DCR, OCR? What is it?
CCR. CCR. Sorry for my. Okay. Okay. Can you tell me what is before I start the chemistry of concrete? So I will talk a lot about cement and its component. Or I will start with that. What is the component of cement? How we can, or sorry. Before that, how we can get cement?
You take
Limestone, clay.
We have how much limestone?
75%.
75%
5.
limestone. And
25
25%.
clay.
25%. You can see because this value is dependent of the type of cement. We have a lot of type of cement. Limestone and clays. Okay, this limestone and this clay have lots of components. Must clay is calcaire in French.
I think so. Argile.
Hmm?
Argile.
Clay c'est argile. Okay, c'est bon. Okay. Okay. From clays, what we get? The so it's not wrong. What is the chemistry composition of the chemical composition of clays?
AL2, 3.
Is
AL2.
SiO2,
AL2.
Al2O3. This is silice, silicate. Okay. This is aluminium. Also F2O3. This is fer. En français, c'est ferrite ou quelque chose comme ça, je sais pas. Mais this is the origin of this is called pozzolans, and we use just this for the color of cement. The gray color of cement it's come from this one. Yes, Fe2O2. Okay. And also we have K-O3 and a lot of things. So it's called alkalis, and we need to reduce its percentage. So we have 20% of that. I think something like that. And from limestone we have the most important thing is this I think you have this. Okay. Calcium carbonate, yes. CaCO3. Yes. After you know how we mélange these two things and we put it in the I think it's called in oven, yes, in fire until 1415 degrees Celsius, and this one it will be CaCO. And this question, I'm sure it will be in the exam.
Yes.
It's about the problem of concrete, and this is the most important problem that I am and all the laboratory here working on. Is two. We have CaO plus CO2. If you have a question tomorrow, what is the problem of cement? It's problem. Yes, it's an ecological problem.
Carbon dioxide, emission of carbon dioxide.
Yes, because the industry of cement is the most polluting human activity in the world. So we need to reduce. That's why we use ECN to replace a part of cement to reduce cement production. Okay? Okay?
Can you say it again, please?
We are using supplementary cementitious material to replace a part of cement in order to reduce cement production. Okay? If tomorrow you see the question, how we can reduce the carbon footprint of cement, it's by heat replacement with supplementary cementitious material or capturing the CO2 emitted by the industry of cement, or we have or just okay. After that, we have, I think, until 900 degrees Celsius, we have this equation. The CaCO3 is transformed to CaO plus CO2. Okay? After that, the heat increase increase until arriving to this value. And we finally get lot of reactions between this one and this one, and we will have the four components of cement that we use here. We have the cement. What is the four components of cement? The first thing is C3S,
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 C2S,
C2S,
C3A,
C3A,
C4F, C4F.
C4F. You know what's mean this one?
One is a light, one is,
What is alit?
I think it's.
Tricalcium silicate.
Hmm?
Tricalcium silicate.
This is alit. Belit.
This is the-
Belit. Ça c'est aluminate, les aluminates. Aluminate. Et ça c'est ferroaluminate. Il s'appelle les ferroaluminates.
It's not ferrite.
Bah, ferrite, comme. Parce que soit on appelle ça, par exemple, soit très calcique aluminate, soit très calcique alumine, soit des aluminates. Par exemple, ferrite, toi tu mais c'est
Tricalcium aluminate.
je sais.
Just the ferrite.
Appelez-le le ferrite, c'est plus simple.
Thank you.
Wait, what was the last one?
Ok. Ça signifie quoi?
Can you
Uh,
not use the red pen? I cannot see it. And I don't, I there's only three things on the board
The
right
problem
now.
is all with all this pens.
I mean, at least the black was visible, and it just became a matter of
Okay.
handwriting.
So,
So wait, the last one is
ferrite.
F-E?
F-I-R-R-O-R-T-E. Ok?
Can you write the formula for it, please?
C4AF. C'est quoi?
You can't.
C4AF, ok? Ça signifie ça déjà quoi? C3S, you know the origin of this? We have 3 CaO plus 1 SiO2. For C3S, for example, from where it's come? We have 3 CaO plus 1 SiO2. 3 calcium silicate. Okay? Now I will do a table. This table is too important to know. Okay? I don't know if it will be in the exam tomorrow or not because I don't see reasons this way. Okay. For each component, I need to know its role. For its role, what do for us for concrete? Why we have this one or this one or this one or this one?
I know alit is for early resistance. Belit is
Okay.
for late.
Alit what?
The first one.
The first one.
Is for early resistance.
No, not so.
Give the strength for short.
I will do a table. Okay? Okay. C2S,
Yeah, early strength.
C3S, C3A et C4AF. Okay. Just pour ne pas dire des bêtises, je vais voir quelque chose rapidement. Il faut forget something. Can I share my screen? Sonia, I have talked before about sulfate attack. external sulfate attack or not?
That
Not
was
for
part
the
of,
part directly.
it was a different class.
No.
Okay. Can you see the... Okay. À court terme, on a...
Can you just push it down?
ah, c'est trop de-
That's what I was trying to
Yeah.
say, it's about.
Okay. Okay, for C3S, we have the resistance court term at every age resistance for C3S. But the contribution of to H hydration is moderate. For C2S, we have the resistance at long term, and we don't know about this. C3A, it should be under 8%, okay? Okay? Because it's too important for external sulfate attack. We need to reduce this one because the sulfate ions react with C3A and the concrete will be fractured. And it gives us la chaleur d'hydratation, the hydration heat. So the concrete will be dry before the sitting time. Okay.
The C3 should be under how much?
C3A
Yeah.
under 8%. Sometimes to regular things, it's up to 12%. But if you have a question about what is the good value for C3A, you should say it should be under 8%. Okay? Okay. Now, if I want a concrete that I need to mold early, for example, I put the concrete in the mold today, and tomorrow I need to demold. What is how I need to have more C3As or more C2As or what? Yeah. So C3S, it gives us the resistance at early age, but not at after a lot of times. It's not contribute. It's to C2S. So we need to find the optimized percentage of all these parameters in order to have reduced the hydration height, good resistance to sulfate attack, also good resistance at early age, and good resistance after. Okay. So it's cost not in Europe, it's in Canada. So. According to European standards, what is the type of cements?
CMI25.
C'est simple. Same from 1 to 5. Same 1, same 2, same 3, same. Okay? It's simple. The worst one that we use all time is the CM1, but now we are trying to reduce its usage. Okay? So, okay. Now we need to talk about the properties of concrete. Do you know some properties of concrete or what? Or not? What is the properties of concrete that we are interested in to study? The first thing is the properties at fresh state. When just we mélange water with cement and aggregate, we have a concrete, fresh concrete, and we need to measure the slab or slab flow. So at early age, we have the slump and slump flow. You know what is slump or slump flow? You know?
Measure the fluidity.
Hmm?
It's a value that measure the fluidity.
Yes, yes, yes. We have a cone and we measure the l'affaissement. Okay, slump flow. Slump flow, in order to reduce the slump of concrete, in order to calculate the slump of concrete, we calculate the diameter. When the concrete is too fluid, we calculate the diameter, and it will be in the case of ECC, we calculate the flow diameter and not the slump, because the slump is sufficient. Okay, at the resistance, we have the most important parameter in concrete science is the F7 You know what is F7 The compressive strain at 28 degrees. Yes. Okay. So, what is the parameter impacting the FC venture? Lot of parameters impacting the FC venture. So, first we have the type of cement. Type of cement. Okay. Type of aggregate. Type of aggregates. Also, we have how we did the test, because when we measure the compressive strength of concrete, we apply a load on a concrete sample. This load is applied according to very normative text. So the speed of descending of the le vérin, and also the diameter of the sample, because we are measuring a cylindrical sample, the diameter of it should be very, very precise to get the good value. Okay, to have a standardized test. In general point of view, the value of FC28, it's between 25 MPa to what? For an ordinary concrete. To
35?
No.
45.
14. 14 or 45? Okay. Okay? And here is the cement who are important. I don't know how to say that. Because we have two types of concrete. We have lots of types of concrete, but one of the types that I didn't read it's BH. UHPS, ultra high performance concrete. In this type of concrete, in this type of UHPC, ultra high performance concrete, the principal cause of crack is not the cement, it's aggregate, because when we apply the force for ordinary concrete, we can see that the cement is cracking. You understand a little bit?
Say it again, please.
We have concrete sample. We apply a load. For ordinary concrete, we have a lot of air voids in cement. So we have propagation of air void, and the concrete and the cement is cracking. In this case, the cement is for ordinary concrete, we should see a good cement. To say in this plage, but it will be good cement. In the case of UHPC, we are using a very low water to cement ratio. You know water to cement ratio? Water to cement ratio is ici c'est the number 0 impacting the resistance, the compressive strength is water to binder ratio. Water to binder ratio high, resistance reduced. Okay? So, in the type of UHPC, you have a very low water to binder ratio, and when we apply the load on concrete sample, we see that the aggregate will crack, not the cement. You understand or not?
At a low water to cement ratio, the aggregate will cook? Is that what you said?
When we are reduced, I will do this way. The first thing, how much water for complete hydration of cement? What is the minimal value of water to binder ratio? 0. What? 0.4? No. Point?
8.
No. Point 8, it's complete with the 10 ampere. It's 0.23. Okay. This value allow complete hydration of the cement exist in our concrete. Okay? So, for the case of UHPC, ultra high performance concrete, we have this value of water to binder ratio, it's 0.3. It's very low. It's just little bit plus the total hydration.
0.23 is the minimum, or and 0.3 for how much?
0.23 is the
Absolute minimum.
is very the minimum. We are not using this value. I haven't seen before concrete with 0.23. Okay. The minimum that we are using is for UHPC is 0.3. Okay. For this values under 0.3 or 0.35, what we have? We have very reduced water to cement ratio, and we don't have air voids. We have air voids, but it's very minimal. So we can have problem with the fluidity. So when we put the concrete, it's set rapidly. We cannot manipulate our concrete because it's too dry, but it's too resistant. Okay? So what you need to know is all the parameters are linked from the quantity of water and cement, water to binder. I call this water to binder. I prefer water to binder and not water to cement, because in concrete we are using cement plus ECN, and all these things are called binder. Okay. Okay. It's preferable to write binder. Okay. We have this water to binder ratio. Water to binder. Okay. Or water to cement as well. This parameter is impacting lots of things. The most important thing is the quantity of air voids, the air in concrete. If water to binder ratio increase, air increase, resistance decrease. Okay?
Sorry, I can't understand.
Okay. If water to binder ratio increase, we have ONOVA, we will have a porous concrete, concrete with a high percentage of pores, so it will facilitate, first of all, facilitate the propagation of the cracks, lot of pores, so the crack will propagate easily. The second thing, it will facilitate the attack of aggressive agents like sulfate or marine seawater. Okay, for example, if we have a building according to we call it I think offshore buildings, so the seawater attack our concrete. Why we are interested in this attack? Because if the seawater penetrates into concrete, it will the chloride will react with the steel bars into concrete, and we have corrosion, and we have fracture, and we have failure. So we need to reduce the quantity of air voids, to reduce the permeability, and we reduce the attack of aggressive agents. Okay. This is the hydration. Okay. Yes. Can you take a photo for this one, please? I don't know if Sonia gave you this one.
Yeah, she gives
Something
something like that, but in
Okay.
English.
Wait.
Can you- can you-
Okay. What is the parameter that's allowing us to link, for example, aggregates? What is the chemical component that we have after hydration reaction?
CSH.
Oui, c'est le CH, le CSH. Le gel, it's a gel. Je sais pas. C'est quoi un gel en anglais?
Gel.
C'est le gel de CSH is the responsible for linking the aggregates. Okay? So we need to increase this one to have more resistance concrete. Okay?
It's important for that.
I will write it. CSH inhales résistance. La résistance, on va avoir quoi? Résistance. If CSH inhales, resistance
Increase.
increase.
Is responsible for something in concrete?
For linking the components. This is the sources of the resistance in concrete. Is the CZ, is le gel de CSH, c'est la source de. How we can get CSH?
With the clinical hydration.
In the previous table, we have seen C3S is the responsible for the resistance at early age. C2S is the responsible after a certain time. So the C said les CSH, C. CSH, c'est soit le C2S, C3S, plus H2O. Okay? We have a lot of type of CSH, and in the recent study, what?
This reaction C2S plus H2O
Because
also produce CH or
we have lots of type of CSH. CSH. The CSH coming from C2S or another type of CSH coming from C2S. The CSH coming from C2S is the responsible for the resistance at early age. The CSH coming from C2S it's responsible for the resistance coming after a certain age. And now we in the recent studies we can see that we have another type of CSH coming from, say, I can erase this. Okay, we have a third type of CSH, it's coming from C3A, so we have C3A plus water give us CASH. And this type of CSH is before I think the recent study we don't know it, but now we can see that it's one of the best CSH. We have a lot of type. The best one is the coming from aluminate. But the problem that we need to reduce this one to reduce the risk of aggressive attack like sulfate attack. Or can you see the problem where? So C3A give us an increased hydration heat. So the first thing we need to reduce C3A. C3A it's react with the sulfate SO4. When we have sulfate maybe come from seawater or used water. So maybe our concrete will be exposed to sulfate attack SO4-. And this one will react with this one, with the C3A, and give us what we call the étrangeite secondaire, secondary étrangeite. And this étrangeite will crack our concrete. So for the second reason, with the hydration heat, we need to reduce C3A to reduce the risk of chemical aggressive things. Okay? But in another point of view, the CSR is the CSH coming from C3A is the best CSH. Do you understand the situation or not?
It's a little bit confused. Like,
We have a
that gonna
confusion
give.
between the durability.
Yeah, so it's give CASH, and then when it's exposed to sulfur, it's gonna react back to C3A, or what?
Le problem in the study of C3A that it's allow a chemical attack. It's increase the hydration heat that we don't like, because when we have a big, huge hydration heat, the concrete will crack. We will have a problem of shrinkage. I don't know if you know shrinkage or not, the thermal shrinkage. But if we can avoid these things, the C3A will be a good component, because the CSH coming from the C3A are the best. Okay? I think it's okay. Okay. Now I will ask you, I think, a simple question. After all what we see, what is the source of what is? Can you just tell me the problems of concrete?
Weak and tensile strength.
What?
It's weak and tensile strength unless you reinforce it.
This is a problem. Yeah? No. You are, for example, you are an engineer. You need to faire la conception to make a concrete, and what is the parameter that you need to increase and what is the parameter that you need to reduce. What is the most important thing?
You want to relax?
Without any question, when we try to build a concrete, we need to reduce the air in concrete. Okay? We need to reduce the pores. Okay? That's why we vibrate our concrete. Les bulles vont échapper. The air bubbles will go. Ça, c'est the weakness zone in concrete. It's the weakness zone is the c'est, je vais dire en français après. C'est la couche mince entre les granulats et la matrice cimentaire. C'est les zones de transition zone, les zones de transition zone. In concrete, we have aggregates, and here we have cement matrix. We have cement and aggregates. Okay. This zone, it's called
The interfacial transition zone.
okay. ITS. ITZ. This zone is the source of weakness in concrete. Because when concrete is exposed to load, the cracks start from here, and if they found some pores, it will be propagated until, okay? So we need one of the solutions that we are using is to reduce the fineness of cement, or we add some ECN or some admixtures to enhance the quality of this zone. Okay? C'est bon? C'est bon? C'est la zone, it's called in French, la zone de transition. So how we calculate the air? So we have a lot of type of air voids. On a l'air entraîné, I think in English, entrained air, that the air will add to concrete, and we can add it with some admixtures. On appelle les entraîneurs d'air. Why we prefer adding some air and avoid some air? Why? Sometimes in concrete we add some pores with some admixtures and some. Why we are doing that?
Freestyle cycle.
Yeah. On appelle pour la résistance gel-dégel. When we have, for example, when we are in Grenoble or Pyrénées, we have ice. So we have, for example, it's running, and we will have some water here in some air. When the temperature is too reduced and we will have ice, the volume of the water will expand, and we need what's on appelle ça en français les chambres de décompression. The rooms of decompression is the air that we are adding first to have more space for the ice. So what I want to say by that is that in concrete we have some airs. We have lots of type of airs. We have nano airs, for example. For the CSH, it's like like paper close to paper, and between these papers we have some air, c'est un nano air. This is important. For example, l'air entraîné, the entrained air in concrete, it's important for freezing cycle, freezing cycle. But for the big air bubble in concrete, we need to avoid it. Okay. Aussi, how we can do a good concrete, it's calcul de la granulométrie. Granulométrie,
Granulation.
yes, because if we need in any case to have a continuous granulometry. You understand? Not, for example, I need to do a concrete in order to enhance the quality of transition zone and also avoid air voids. I need continuous granulometry. For example, I need fine cement, after the fine aggregate. This is, for example, the diameter of diameter. I need, for example, the diameter of cement is that. The diameter of cement. After that, sand. After that, aggregate. So I have a continuous diameter of. For example, I will not use cement. The diameter is here, and after that, I will use coarse aggregate is here, and I will have a gap here. In order to enhance, just what you need to remember. In order to enhance the quality of concrete, I need to optimize the granulometry of this concrete. Okay, the granulometry of the components. Okay. C'est la granulométrie en français. La granulométrie, elle influence la qualité de la zone de transition. The granulometry impacts the quality of transition zone. That's why we are using sometimes fillers. You know what is filler? Sometimes where is MCL, it's called filler. The diameter is too low, so it can fill the transition zone between aggregate and cement matrix. Ça, c'est les paramètres impacting the compressed resistance. Here is the mixing water. We need to use good mixing water, not using water who contain aggressive agent that it will impact our concrete. So there also is one parameter. But tomorrow, if you have a question, what is the most important parameter impacting the compressive strength of concrete? Is water to binder ratio. Okay.
Water ventilation.
Water to binder ratio. C'est W sur C. What is the most important parameter in concrete science is water to binder ratio. Okay? It's impact the porosity, it impact the compressive strength, it impact. After melanging our concrete, after mixture, we need to protect our samples. Why we need to protect it? To not have been dry with, for example, from heat or something like that. And we will lose some water, and the concrete will be not totally hydrated, and we will lose some resistance. Okay, we are searching to have not an excess of water, and not very, very low water. Okay? We are searching the 100% of hydration, not more, not less. If we have less, if we have more cement and we don't have water, so it's lost resistance. So this cement could be used to resist. And if we have a lot of water, we will have pores and water to body ratio will increase and we will have some problems. Sorry for my English, it's too bad, so because I give the courses a lot of time in French, and for today I don't want to do that, just to, because I see you are too stressed, so I want to have a global view of concrete, but what I want to do today is to show you very other topic. It's how we can use machine learning to optimize concrete. You know what is machine learning? How we can use machine learning to optimize concrete formulation. I will give you the PDF of the course, and please read it at your home. Ok. Ça c'est quoi la cuve? C'est quoi la cuve? Curing. Il y a two types of curing. Il y a la cure humide. Why we are what is la cure humide?
What? What?
Humid curing. What is when we do concrete and we put it into water. Why we are using that? To have a total hydration of our cements. Is the best type of curing. We do concrete, we protect the surface, and we let it 24 hours, and after that we put it into water for example 7 days, and we will have the maximum resistance. Why we cannot do this into situ? Why?
Can't build a tank around an entire
Yes.
building.
For example, for this building, I cannot put it into water. For example, for this photo, I cannot put it into water for 7 days. So we are doing what we call the la cuve sec. Just we protect the surface of concrete to not have séchage, and sometimes we do what's called arrosage. We put some water on our concrete in order to get the best performance. So it's called ça, c'est le mûrissement.
Can you go back? What is the difference between
This is
moist curing the entire time and in air after 28 days? Because if
this
it's
is the development of the resistance depending on the curing type.
yeah, but like I mean practically on a practical level, if concrete reaches its max strength typically after 28 days curing, then what is the purpose? Then what does it mean to moist cure the entire time? Is that when you submerge it until 28 days? What's the difference between the blue one and the pink one?
This one, c'est
Not that one.
c'est un cure à sec. We didn't put it into water.
Yeah.
For this one, 7 days.
In air after okay, yes.
For this one, 28 days. And for this one, it's still for all
So
time.
28 days of moist curing?
Yes,
Yeah.
28
And
days
then-
of.
But if it reaches its max strength after 28 days, what, is it done? My brain is so broken, I don't even know the question. If concrete reaches its max strength after 28 days, why would you need to moist cure it the entire time? It's cured after 28 days, no? Right?
But the hydration reaction is not stopped until 1 year, 2 years. All time we have the reaction hydration. We have very low water quantity. For example, if I brought this one and I put it until its microscope, I will see some air bubbles and some waters and some what's it called? It's called some cement. That's why after demoling the building, we are using this wash to do another concrete because this building it's contain some cement that not have been hydrated. Okay. I don't know where is the other figure because I have showed a lot of course, but I have figure with the development of I don't know if it's here. It's here. The hydration reaction is not stopped until we die. Okay. 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 Sorry if I missed something because I wasn't prepared for this type of talk. So of course I just want to give you a global point of view of.
Can you say something of Professor Allen? Question about Professor Allen?
Okay. I will search the exams for Anna and I think I will send it to you if I find. But for Professor Anna, what you need to remember is I think he will give you the curve of l'ouverture de la crack opening with the coefficient A, I think. And all the things are in the, yeah. I think, this is the cause of, this is the cause of Adam.
Yeah.
Can you see please?
What slide is that? It's not
But deeply, sir.
But for Alam example, he will give you the equation that we need to use. So, okay, it will not be very difficult. Yes, I think for our case, he give us the equation.
We don't have to memorize. We don't have to memorize.
He told you to bring with you some paper?
No.
Close
It's not allowed. Huh?
I don't know anything.
I'm Jon Snow, dude, I don't know anything.
We have no information about his exam at all.
What advice I advise you to do?
I asked him about the question paper. He said he's going to give the more theoretical question than the equation-based question.
Super.
In any case, what I advise you to do, to bring the courses with you. Yeah, just the notes, not all the. I think for Alam case, he allowed one paper. Huh?
He didn't mention anything.
He's going to do it or not.
It's a bit late.
He was not sure about the question he's going to do for this course or not.
No, for Alam path, I think it will. I think because for cement chemistry, the maximum is 45 minutes, not more.
Which is almost half of the
Mhm.
exam, sir.
Can you just give me the names of the professor who you for this course you have?
Mr. Benoit Luna, Buddha.
Benoit Iluna, the part of Benoit Iluna will be here or not?
No.
We don't know.
No?
No.
Yes or no?
No.
You don't know anything?
No.
Okay.
It's only Udash and Allah. It's only the city.
Okay.
That is what we got from email
That's
from Udash.
Because when I asked him,
It doesn't make sense, but it's what we got.
I think that you need to focus on the cement hydration, okay? The chemical component of cement, each role of these chemical components, okay? also the problem of concrete and cement. What is the problem of concrete and cement?
CO2.
Related CO2. Je pense some admixtures. Why we are using superplasticizer? Why we are using entraîneur d'air? Air entraîné. Why we are using air entraîné? Why? Can you answer me? Pourquoi on utilise yes, les entraîneurs d'air, les admixtures? Okay. The percentage of each component in concrete, you need to know it, and it's all. In any case, for the exams of Sonia, it will be easy. If I had the chance to do my course today, I will give you a project to increase your point a little bit, your marks a little bit, but it's okay. For Alan Pass, in any case, it will be unchanged, it will be difficult, so.
Thank you.
Not difficult, but
You just said difficult,
just not,
Not straightforward.
not easy.
I don't know your level, because it's the first time I saw you, but just not,
See this slide then.
not give the
Did you
paper
wrote,
empty.
did you wrote any of the exam questions?
Hmm?
Did you wrote any question of the exam?
You know, you want exams?
No. Did you for tomorrow's exam?
Mm.
Did you personally wrote any of the questions or not?
It's for the exam of Sonia and Alan. I know the structure, how it will be.
But you don't know the questions.
No, I didn't see it, but I know it because I did with them a lot of time the same course, and last year I didn't do it because I wasn't in France. But normally what we do is me and Sonia we separate the exam into two parts. But this time just her, so I think she will give her part with some additional questions. But in any case, it will be very easy. Just if you read the slides, it will be very easy. Okay?
Are you correcting the exam or?
No, it's Sonia who will correct. But you have chance. I prefer that Sonia correct, not me. For me, I insist on details, and I want to see the answer that I want, not. But Sonia is too flexible. It's better for you. Okay? How much hour we have for this course?
Oh, yeah. We should finish today's class at 6.
Do you have some questions?
Can you make us all pass during the exam, please? Can you talk to all the teachers and make everyone who are here pass the exam? Even though we only wrote our name on the paper, please, please make us, let us pass.
But this course is, I think, most important one during your study process. After that, we will. I think you had some courses with Julio Shara, Porous Media.
We had this one already.
Yes, Porous Media. So you will have homogenization. Yes. And this ones are.
You get it.
Sorry, but,
Okay.
but for this one, it's very important for your career.
But this one is like too much.
Not too much.
No, the
Yes,
courses are already
especially what you do, what you give the exam.
not organized.
So
To be honest with you, the exam will be easy. In my promotion, I did I think the same answer 3 or 4 years ago. The exam, the easiest exam during all the year is this one, because we know what we will have in the exam.
But we don't know.
But we actually
But we
don't.
don't know.
Not like Boros Media, he give you I think 4 papers, 8 papers to read and.
So,
So since you know a little bit about homogenization, they have that exam next week. What can you tell us about it? It's Professor Ciara.
Ciara and François Bignolet,
Yes.
quelqu'un d'autre, Grandin je pense.
No,
Frédéric
that was,
That was
that
for-
was-
Or
Yes,
student.
Grandin.
No, I think you have 3 professor for.
Yeah, that's
Homogenization.
Professor Patrice Cottrell as well, for homogenization.
Qui?
Patrice Cottrell.
Control.
Thomas.
Control.
Panagiotis Kotronis.
No,
No.
no, control, Patrice control,
Ah, Patrice 4.
Yeah.
Oui, oui.
yeah, and also Ben, and then Ciara.
If you want to get some good marks, I think the easiest part for François Bignolet, yes, it will be too easy. Because for Julio, he will give you big matrices
Yeah.
and you will write
I'm
calculate
happy
in
with
the
this.
mistakes.
just let it
So
go.
you need to revise
It's
more
Julio.
to
You
revise
must
more
PTSD to
the
every
part of
student.
François
But
Bignolet.
it's gonna be 2 or 3 different.
Because for François Bignolet course, you have just some cases with calculation. It's easy, I think. You have a lot of cases, and for each case you calculate the C.
Yeah.
Yes, it's easy. It's not like having huge matrices and you need to calculate a K. But in any case, the professor are generous in giving marks. That's what I know.
Not sure.
How much are they generating?
No.
Can I go to
Have you failed an exam before?
Of course, we.
Oh God, don't even put that into the ether, why would you say
In
something?
Boros Media?
Yeah, he graded it.
Him and Grandin were
Grandin?
his course meeting.
Ronda gave me 5 over 20 in the exam. I still remember it until today. And now we are working together.
Wait, he accepted you as a doctorate student?
I'm working with Lokili.
Oh,
I'm Lokili who
I
said
would
you
never,
anyway.
I would be terrified to have a professor whose exam I
Just,
didn't
you know, it's one of, not the one, it's the best director. If you grow that, if you do PhD with him, you will be.
I would never.
Who will do PhD here? Ask the class who will go to a PhD here.
You don't want to be PhD students?
Not me, for
I
sure.
just want to pass.
I don't
You need to pay me 10,000.
I don't want to be a
at least.
PhD. That's so
For me to
funny. I
consider
barely
it
want to be
a
alive right
Oh,
now.
at
I'm
least
actually going to
10,000.
a PhD.
All my class did PhD.
Wow.
None of this class will do PhD, sir.
We're not.
Your
100% sure.
Everyone in your
Yes.
class,
How many were you
they didn't survive.
How many people?
were in your class? How many?
12.
Were they all central non-student from beginning to,
We start together. We did an internship together. 3 stay here in Central, 3 other I think in Faculty Center. And after that, all us, we did PhD.
after my, why didn't you guys go get jobs? Like, was it that
And now,
long?
this year in December, just me, I didn't defend yet, but all the class have defended the PhDs.
They should have started their first semester. For us, we have to do different countries. If they started in Germany, they would want to
Most
continue.
important thing that I think you will have to find projet de fin d'études, PFE, master internship.
Yeah.
Vous allez galérer avec ça.
Thank you very much, sir.
You will have
I
some
need to
problem
hear that.
to find this type of stuff. Why? because you study, you are English people, anglophone, you cannot talk in French. The second thing, this master is research master,
Yes, that we don't know before admission.
so the companies will not accept you. So you